happy Friday. So we're in your notes packet. We're kind of jumping around in your notes packet. So we are going to be on the page that says Roman numeral number 2, navigation. Okay, so that's where we're going to start today. And we'll do that one single solitary page. It's a word problem page. Finding it. There it is. I see it on the edge. One more. Right there. That one. Yep. Okay. So we moved the formative back to Tuesday. We also are going to ask that you watch a video this weekend on Canvas. Okay? It'll be posted this afternoon if I can find it off of our old learning platform. If I can't find it, then I'll just re-record it tonight and I'll post it this afternoon. Okay? And so we'll have you watch a video. It'll be short. It's an under a 15-minute video that you got to watch sometime between now and Tuesday. But you're going to need it for Tuesday. So this time you need to watch it. Okay? Right? Because not a lot of people watch, or I shouldn't say not a lot of people watched it. Most people watched the video from over on last Tuesday when we didn't have class, but you had a video, and then some people got burned because if you turned in your worksheet late, we're not giving you credit for it. Okay? So, because you didn't do what you were supposed to do, so that's your punishment. Okay? So all good things. So up at the top of that page, there's a little blank space that we're going to fill in right now. Okay? So we've got navigation. And navigation angles can come in one of two forms. Okay? The first form is that it can come in an angle form. Like a plane is bearing 300 degrees. Okay? And if that's the case, then you're on north is up here with 0, east is over here with 90, south is down here with 180, and west is over here with 270 degrees. Okay? So you plot where that angle goes. Okay? The other form that it might come in that north, south, some angle, east, west form. Okay? Now remember, that one comes off of the north-south line. The vertical line is where that angle comes off of, either to the west side or to the east side. Okay? So you got those. Either way, no matter how your bearing angle is given to you, the very first thing you need to do is you need to convert that angle. Oops, I forgot the V. Got to convert it to a trig angle for all of your calculations. So if the problem says that you're bearing 300 degrees, that doesn't mean you get to use 300 degrees as that angle for the rest of the problem. And you got to convert it back to a trig angle. Okay? And what is that? That would be 150 degrees. The trig angle for that. Okay? So just know that you've got to convert that into a trig angle. Okay? So now let's talk today. Okay? And don't be mad at me. I'm going to use you as an example. You're going to be my plane because you just flew on a plane over here to America. Okay? All right? So when the Germans, the German students that we have visiting us these next couple of weeks, when they flew over here, their pilot and their plane's computer made all of these calculations, like constantly they were making these calculations that you're going to make today. Because when they flew over here, so if they're flying from Germany to the United States, I'm going to go the other way. When they go home, when they fly from the United States back to Germany, they're going to fly. And if there's no wind, they're going to fly directly to Germany. And everything's fine. Okay? The problem is that there's this thing called the wind. Okay? Or if you were taking a cruise, there's this thing called the current. Okay? So if Hurricane Zoe's blowing over here in the Atlantic as we're flying to Germany, okay, now that's going to have an effect on my plane, and all of a sudden I'm going to end up in Finland. Okay? Which isn't a bad thing. Okay? But it's not down home in Germany. Okay? Okay? So we have to take into account wind, current, anything else, any other forces that act on our vessel. Okay? So in order to do that, you use this simple vector equation. A plus W equals G. Where A is your plane, your boat, your hot air balloon, your parasail, whatever you want to call it. Okay? That's your vessel. Okay? W is going to be whatever is acting upon it. Wind, the current of the water, Hurricane Zoe, all those things. Whatever is acting upon your vessel. And that then equals your true vector. And from that true vector, you can get speed. What's the speed of a vector? How do I find the speed of a vector? Our vocab words. Say it loud. Magnitude. Okay? So we can find the magnitude, which is the speed then of the actual speed that's being read on the airspeed indicator in the cockpit. Okay? And we can find the actual direction that we have to fly in order to make it back home to Germany. Okay? Okay? So we get all of that from that. Okay? So let's do an example. Here we go. This is the one right below that. You don't have to search for it. I know exactly where it is because I didn't search the last time. Okay? So a plane has an airspeed of 450 miles per hour on a bearing of 150 degrees. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? Well, so that's going to be an A plus W equals G, vector equation. Our vessel is a plane. It has an airspeed of 450 and a bearing of 150 degrees. Okay? So this 450 is a speed, correct? So what is that of vector A? That's the magnitude of vector A. it has a bearing of 150 degrees. That's my vector's, oops, I put V there. That's my direction angle, correct? So the first thing we need to do is we need to convert that to a trig angle. Bearing of 150 degrees. Which quadrant am I in if I'm bearing 150 degrees? 4? Quadrant 4. Okay? So I'm down here. I've got this angle right here is 150 degrees. What is my trig angle? 300. 300? Do we all agree with 300? 90 for the first quadrant. That leaves me with 60 left over, which would put me at 300 for a trig angle. Okay? So how am I going to find, then, vector A? Based off of maybe the previous page. How am I going to find vector A? It's an in general box. Of what? So, give it to me.
450 times the cosine of 300.
Because I use the trig angle because I'm computing.
Yeah.
Yep.
Comma. 450 times the
Okay. Now, we're going to be doing some calculations with these, correct? So we want to leave them exact as we can. Luckily, 300 is a unit circle angle. Okay? So what is 450 times the cosine of 300? So the cosine of 300 is 1/2, right? So 1/2 times 450 is 225. What is the sine of 300 degrees? Negative root 3 over 2 times 450. So negative 225 times the square root of 3? Because 450 divided by 2 is 225. Okay? I like this early in this problem, a heck of a lot more than I like negative 389 point what? What was it? Negative 389.71 something something 77389. Okay? Alright? Exact, heck of a lot better than rounded. This early in a problem, try and keep it as exact as you can. Now, if it's a non-unit circle angle, you're going to have to round. Try and keep it as many decimal places as you can until the end. Okay? So that's vector A. So vector A can go over here, and we can say that's going to be 225, negative 225 square root of 3. Then we got to add to that vector W. So now we got to figure out vector W. That's going to be what's affecting my plane. Well, that's going to be the wind here. The wind has a bearing of 60 degrees, and it's got a speed of 50 miles an hour. So the first thing that we need to do is we need to figure out the trig angle of the wind. Okay? Wind is blowing with a bearing of 60 degrees. Which quadrant is the wind blowing to? Quadrant number 1. Okay? So that would have me right up in here, where this is my 60-degree angle. What is the trig angle associated with that? 30. So my wind vector then would be 50 is the magnitude times the cosine of 30 degrees. 50 is the magnitude times the sine of 30 degrees. What is the cosine of 30 degrees? Root 3 over 2 times 50. Sine at 30 degrees? 1/2 times 50. 1/2 times 50?
25.
Okay. I'm never going to ask you a question that you don't know the answer to, just so you know. It's pretty tough, yeah, it's a little. Okay? So then that can go over here for vector W. Now I get it. Okay? This is where I got frustrated. Hurricane, so this is where I got frustrated last time. Because I asked them. I know I'm a bad teacher, but I asked them to remember something from before spring break. I know. Meaning. But then we also did it this week too. So that's why I didn't think it was that bad. Yeah. So how am I going to add vectors? This was their reaction. You add the horizontal components, you add the vertical components, right? Yeah. Yeah. So this is going to be, so vector G over here is going to be the vector 225 plus 25 square roots of 3, negative 225 square roots of 3 plus 25. Question, Luke?
No.
Oh, okay. Gotcha. Okay. Now, if we wanted to stay exact, we could use those then going forward. But now we're well into the problem. We could probably just figure out what those are in their decimal form. Okay? So 225 plus 25 square roots of 3 is how much? Let's go to 3, at least 3 decimal places. What do we got here? Look. You chose the right person to check with. The y, the vertical component, negative 225 square roots of 3 plus 25. Okay? So that is the vector of our true ground speed and direction. But that's the vector of it. How do I find what the actual true ground speed is? We'll do ground speed first. How do I find the actual ground speed of this plane flying from the United States back home to Germany? Got to find the magnitude of G. So the magnitude of G is going to be what? Square root of x squared plus y squared. What do you got? Anybody?
I round to seconds, but I got 452.77.
Okay. We all in agreement with that? Okay. How do I find the direction of the plane? Tangent -1. What is this? What is
My
this
bad.
devil tree that you're using?
My bad. Inverse tangent.
Of? You just give me the two letters.
Y.
Y over x. Okay. Now, is that going to be my actual direction angle, or I should say the trig part of that, or is that going to be a reference angle? Why is it going to be a reference angle?
It's giving you like that interior angle from whatever horizontal.
Why is it going to be a reference angle?
I don't know.
Because we're in quadrant 4, we're not in quadrant 1.
Oh,
Yep. What do I do? Follow-up question. What do I do with the negative sign on the 364.711? Drop it like it's hot. Drop it like it's hot. Oh, I dropped it like it's hot. Just so you know that's a video. Yeah. It's a horrible video. I love it.
Didn't you say something about
His girlfriend left him. She's a horrible person.
Yeah.
Yeah. Right in the video.
Yeah.
It's hilarious. Okay, so what do we got for an angle? What do you got for a reference angle here? Okay, that I like better. You had me, then you lost me with the 2. Right? But now, if this were trig, we would say, because it's in quadrant 4, we would subtract it from 360 degrees, and then that would give us our actual angle, correct? But we don't have to do that step because it's a bearing angle. So we said that we were in quadrant number 4. We said that this 53 degrees was our reference angle. So it's there. We need the actual bearing angle of this plane, and that starts from the north and comes clockwise all the way down to there. So what is the actual direction angle of vector G?
Could you write it like the south?
We'll get to that. Yeah, we'll get to that in a minute. Okay? How did you come up with the 143?
I just added 90.
Added 90 because we had it add in quadrant number 1. Okay? So in the end here, the plane's true speed would be 452.77 miles per hour, which that means that the wind is the wind pushing or pulling us. Is the wind helping or hurting us, I should say? Helping, because it's pushing us along. It's making us go faster. Okay? And the actual angle, the actual bearing, is 143.66 degrees. Now the question was asked, what about the north-south direction, east-west then? Okay? And our response to that is, if we give you, like in this problem, flicker there are the lights. If we give you the problem with angles, with straight up angles, give us the answer in angles. If we give you the problem in the north-south angle east-west, give us that one then for your answer. So whatever the problem, whatever form that the problem is in, that's what we want for the form of your answer. Okay? The other thing that I want to just remind you of is the fact that there will be a video to watch this weekend, sometime before class on Tuesday. Watch that video. It'll be posted on Canvas this afternoon. I just have to, next class, they're taking a formative, so I'm going to go find it, post it up. So it'll post up hopefully by noon. Okay? That's all I got for you.